We ended our third segment of this lecture by discussing the idea of reaction norms or phenotypic plasticity. So remember that reaction norms are the range of behaviors that are possible from a given genotype given different environmental input, and that phenotypic plasticity refers to the ability of an individual to modulate their phenotype, holding genotype constant given different environmental input. And so in part 3, we were discussing specifically how traits like red blood cell density might vary based on where you find yourself, what kind of environment you find yourself in. And so we were talking about how in low oxygen environments, typically high elevation, you have a greater density of red blood cells per unit volume blood, and that in low oxygen or high oxygen environments, typically low elevation, you have lower red blood cell density in a given volume of blood. So this really ties in then to this discussion of behavior, because behavior is incredibly plastic, particularly when we look cross-culturally. We've got different ecological environments, but we also have different social and cultural environments. And so we would expect, if behavior evolves, that it's going to be through this evolution of reaction norms, that it's going to be through the ability to alter your phenotype based on environmental input. And so before we go any further, we're just briefly going to talk about what we call levels of causation. And these were outlined by Tinbergen. And they're not mutually exclusive. What that means is that for any given behavior, you can explain the causation of that behavior at any one of these levels, and the other levels are still correct. So what Tinbergen did was stratify these explanations into four kind of broad categories. And we typically find that that a given discipline will predominantly focus on one of these four levels of causation. So the first one is proximate causation. This is really the how of the behavior. This is what makes this behavior happen at any given moment. This is the actual mechanism by which the behavior occurs. And so we find this quite typically in evolutionary models of human psychology, for example. So next week you're going to have the opportunity to watch a couple of films, The Human Quest Part 1 and Part 2. And in that, they're going to bring up the example or the statement that the human brain is like a Swiss Army knife. And what that means is that we don't have a general processing unit, a brain that's kind of a blank slate and can be programmed in many different ways. Instead, what we have is a brain that has specific areas that are then associated with particular functions. So, if you're going out into a survival situation, you probably don't want to just have a 6-inch paring knife. I mean, a 6-inch paring knife can be useful, but only for particular kinds of activities. And so the value of the Swiss Army knife, by contrast, is that it has multiple tools on it that allow it to achieve different functions. And so if you need a corkscrew, right, to get a cork out of a bottle of wine, or let's say you've corked water for like long distance travel, the corkscrew would be the tool that you would go to, not the scissors, for example. Similarly, if you've got to cut some wire or something to set up a snare for trapping, you're going to pick a particular tool. You're going to pick something like the scissors or wire cutters or even the sharp knife versus the corkscrew. So what we really see is this focus and this ability to pick the appropriate tool given the particular problem that needs to be solved. And so, when talking about your brain, you'll often hear in psychological explanations that are utilizing evolutionary theory that you'll hear discussion of what we call domain specific modules. And so, for example, we have learning or language centers in our brain. And those language centers are going to be the regions of the brain that are activated when you are tackling language type tasks. Similarly, we may have areas of our brain that allow us to make mental maps. We may have areas of our brain that are associated with emotions that are felt deeply. We have areas of our brain that are associated with planning, etc., etc. So when psychological explanations look for this level of causation, they're often looking for the regions of the brain that are specifically associated with that function. So again, the proximate explanation reflects the how of a given behavior. The ontogeny affects how the machinery develops as the organism grows. And so this is related to how decisions may change, how traits may change, how behaviors may change given your stage of development. And so we can certainly, when looking at tasks that involve empathy and theory of mind, we note that before about the age of 4 or 6, children aren't capable of really putting themselves in other people's shoes. After about the age, somewhere between 4 and 6, they are. Similarly, when we look at the development of morality prior to the onset of puberty, children have a difficult time thinking of shades of gray. And so they'll find, in terms of an ethic or moral situation, they'll find that it's black and white. It's either right or wrong. After the onset of puberty, they start to understand that it's not really so easy as to say that lying is always wrong, for example. That there can be cases where lying can save your life, where lying can protect other people, so on and so forth. And so we recognize that with respect to human behavior, we see differences in behavior among infants, toddlers, children, teenagers, and older adults. The phylogenetic explanation gets at how the behavior systems of each species evolved until they became what they are now. So there's been it's been rather popular by Frans de Waal and other researchers who work with chimpanzees to, of course, use them as models for human evolution, which is absolutely appropriate as they are our closest living relative, provided, of course, that we recognize that they have also, though, had 5-6 million years of separate evolutionary development, evolutionary time, evolutionary specialization. And so they've been used, for example, to model morality, to model the evolution of human moral systems. And both capuchins and chimps have been observed to have a notion of fairness and to adjust their behavior based on whether rewards are considered fair or not. And so this has then been used as evidence to state that perhaps we share this kind of framework of morality not only with other human populations, but with other primate populations as well. And so that's just one example of the sort of trait that we might look to, or the reasons we might look for a phylogenetic level of explanation. And then lastly, we have ultimate. This is really what anthropology is interested in addressing. This is the why of the behavior versus that how of the behavior. And so specifically looking at in what ways does this behavior influence the survival and success of an organism. And remember that we have really tried to hit home this impact of fitness and the importance of fitness. We've got to have certain criteria met in order to have evolution by natural selection. And those criteria are the kind of framework that ties the outcomes of selection, the outcomes of decisions to our evolutionary fitness. So it's surviving long enough to reproduce, and once we reproduce, being able to keep our children alive, our offspring alive, until they are at an age that they can reproduce. And so it's the ways in which traits, decisions, behaviors affect survival and reproduction. And so when we look at the ultimate level of explanation, we want to relate it to how does it affect survival? How does it affect reproduction? And so it really is getting at the why of the behavior. Why has evolution favored this behavior? And so we're going to go through an example and just demonstrate how these are not necessarily mutually exclusive, and any single behavior that we can think of can be explained at this at each of these four levels of causation. So I'm going to pick sexual arousal simply because, I mean, at the Y level, the ability to become sexually aroused is very closely tied to one's reproductive success. You're not going to be as successful in terms of reproductive output if there's not some kind of feedback mechanism that leads you to seek out reproductive opportunities. And so at this proximate level, when we're looking at what makes this behavior happen at any given moment, we could look to the human brain. We could look to the areas of the brain that activate with feelings of lust. We could look also to the way our hormonal profiles change at the onset of puberty. And so at the onset of puberty, the pattern of gonadotropin releasing hormone secretion changes. It's very cyclical in females. It's less so in males. This triggers then follicle stimulating hormone and luteinizing hormone, which influences then gamete production and kind of the whole cascade of emotions and behaviors that then impact reproductive success. And so we could look at functional hormone levels. We could look at how visual stimulus is processed and then reinforced. We could look at increased blood flow, particularly to the genital area, that leads to engorgement of particular genitalia, like the erection in the penis, and the increased blood flow that also leads to the engorgement of the clitoris. So all of these would be appropriate proximate levels of explanation. In terms of the ontogeny, this is where we're really going to compare across phases of development. So we have this stereotype of the average adolescent male, human male, thinks about sex once every 7 minutes. At least that's what the stereotype was put forth when I was in high school. But there's some truth to that, in the sense that prior to the onset of puberty, we don't experience very much sexual arousal. That, of course, doesn't mean that male infants and toddlers aren't capable of erections. They certainly are. But the cascade of thoughts and the cascade of hormones that lead to those erections under manual stimulus are completely different, not really cascade geared towards reproductive success. At the onset of puberty, hormone profiles change, so on and so forth. Genitalia grow, so on and so forth. Our capacity for orgasm emerges, so on and so forth. So similarly, at very old ages, we often see a decline in sex drive. And so it's harder for older individuals to become aroused, hence the need for pharmaceuticals like Viagra. And we recognize, too, that particularly for women, there's a cascade of hormonal changes that leads to perimenopause and then full menopause, the cessation of reproduction. That doesn't mean that women who have progressed through menopause are incapable of becoming sexually aroused, rather that hormone profiles have changed. When we look at the phylogenetic level of explanation, we would look across really at the first stab all sexually reproducing species. when you reproduce sexually, there's got to be some kind of mechanism that leads to positive feedback of engaging in sexual behavior. And so, typically, we've got this rule of thumb of if it feels good, do it. Particularly, for other species, they don't have the same kind of moral framework that they ascribe to behavior. And so we see phylogenetically that sexual arousal is capable at times when there's a high likelihood for success of reproduction. So, for example, in Paramyscus species of mice, this includes the white-footed mouse and the deer mouse, they're seasonal reproducers. And so they specifically experience greater sexual arousal, greater sexual incidents of intercourse, etc., opportunities during spring versus winter or fall. And so we see the hormonal profiles of females change such that the opening to their vagina is only actually available and open during estrus cycles. At other points, the opening is closed. And we see that males undergo seasonal increases and decreases in the size of their testes. And so if you trap one of these mice in the fall or in the winter, their testes are going to be very, very small. As spring approaches, their testes will undergo rapid growth and will remain very large throughout the breeding season, and then they'll shrink come the end of the breeding season. So there are certainly with testes that grow and then shrink, different levels of hormones that are secreted that help to facilitate sexual arousal and sexual reproduction. And then lastly, this ultimate level of explanation. How does experiencing and the capacity for sexual arousal influence one's fitness? Well, I mean, this is probably the easiest level of causation for us to explain, because sexual arousal leads to sexual intercourse, which, if that is undertaken with the right period of time, can result in direct reproduction, which of course will then increase your overall fitness. So the evolutionary implication of sexual arousal is that if it feels good, do it, right? That we get a positive feedback loop established, that when we have pleasurable sexual experiences, we are more likely to seek out other sexual experiences, and then we're going to experience greater overall reproductive success and greater overall fitness. So just with one particular behavioral example, we're able to see that we're able to explain it at each of these four levels. None of those explanations are false. None are more correct than any of the others. It just depends on what the particular question is that you are asking. All right, so that brings us back then to language and evolution, or learning and evolution, sorry. And specifically what we want to address is, do we have an evolutionary basis for learning? That is learning something that has been favored by natural selection? And if it is, how does that present itself? Learning mechanisms are evolved structures of the brain, and in particular, among very social species who have also a long period of time of learning and development, we find that a lot of the mechanisms for learning are present in the forebrain or the prefrontal cortex. And so we can look in terms of our phylogenetic relationships at our evolutionary ancestors and our most closely related other species, and see what we might be able to measure, what we might be able to compare. So we do expect that because brains help facilitate learning, that since brains evolve, learning is likely to evolve as well. There should be some things that we are able to learn more easily than others, and other things that we really have we struggle to learn at all. And so, my kids are middle school and high school age, and one of the common things that I hear, particularly among my daughter's friends, she's the one who's in high school, is I'm not good at math, or my brain doesn't understand math. And so, there's been a lot of commentary surrounding math performance among middle and high school age girls? And do we really have something in our brain that makes it more difficult for us to learn math and understand math and express mathematical relationships, or is this something that girls have been socialized to feel and to think? And kind of this whole nature versus nurture debate, and the role that socialization plays in reinforcing certain neural connections and brain development, etc. This is not. I'll just give you the long and short of it. That's not the case. There's nothing inherent about female brains that makes them unable to learn math. It has much more to do with the messages that they get all along the way in appropriate gender roles and gender socialization. And so from infancy on, when they're given messages of what matters is beauty, oh, you're so pretty, you don't have to be smart, that kind of thing, then naturally they're going to think of themselves as less capable. But when we look at this idea of being able to learn some things better than others, think about the ease with which children learn language. There are periods of children's lives where they have very, very rapid vocabulary acquisition. Really, there's a language explosion between about 3 and 6 where kids can learn 20 or more new words a day. And it's really phenomenal. And if you have not had children yet and you plan to have children in the future, I mean, it's going to be remarkable. You got to be careful what you say because they will repeat everything that you say. Yesterday, my 3-year-old was sitting in the car. I'd texted my spouse, and he'd had Siri read the voice text, and the word 18 was used, and then the 3-year-old was just sitting back in the back of the car. And the reason that this sticks out in our mind so much is because our 3-year-old is language delayed, and so he's about a year behind in language development. But the rest of the drive home, he's just sitting back there going 18, 18, 18. So we do have periods, and in general, language, not necessarily second language, but our primary language is very easy for us to learn. Compare this then to the ease with which we learn reading and writing. We don't have similar sorts of kind of reading and writing explosions. And in fact, reading is one of the behaviors that is so critical in public education and our educational system. However, it's one of the hardest things for kids to master. And I've often heard my parents were career educators, and I also have a lot of friends who teach anywhere from preschool to the university level. And for elementary in particular, I've always heard that first or kindergarten through third grade is focused on teaching kids to learn to read, and that at about fourth grade or fifth grade, you start teaching kids to read to learn. So what does that mean? Well, that means that really all of the work that's being done in those foundational years, lower elementary, is focused on literacy, is focused on kids learning how to read, the mechanics of it, and also the being able to understand what you read. It's not until you're at about a fourth or fifth grade level that you are able to start to use those skills that you've learned to learn new things. And so you're not just going to give a second grader, even if they have a high reading level, you're not going to give a second grader a college textbook and then say, okay, now you're going to reverse engineer a plasma car or something like that, right? They're simply not going to be able to do that. It takes us a very, very long time to be able to learn to read and write. It should be very easy then for us to learn behaviors that are strongly favored by natural selection. We're going to, in the film next week, you're going to hear some conversation about human universals. These are behaviors that all humans express even after we control for ecological cultural differences. So they are really at the root of our humanity, and these represent adaptive responses to very old selection pressures. So, for example, one of the behaviors that it'll talk about in the film is motherese. This is the tendency of women in particular when talking to young infants to turn their voice into the sing-song way, because what you're really doing is trying to get their attention. That lilt that we use when talking to young infants, or even my grandmother did this till the day she died with her dog. So and a lot of people do also use that kind of motherese for communicating with their pets. If I were to do that, if I were to present my entire lecture in motherese, you guys would think I was off my rocker. You'd think I was totally crazy. Why do we have motherese? Well, because that helps facilitate language development in infants, because what infants are listening to is not what you are actually saying. What infants are listening to is how you are saying it. So they're picking up on the melody of what you're saying more so than the actual content or words that you are saying. And so this is something that is natural for humans to do, because this is something that kept our babies alive for millennia, over the course of our evolutionary history, really for millions of years. Using motherese, having a different style of communicating with infants versus adult individuals, help to keep our infants alive. All right, so Garcia did some really savvy experiments with rats, really about 40, 50 years ago. And rats are of course, a very common kind of experimental group. They're really easy to breed in the laboratory. They're also really incredibly smart. I mean, they can run mazes. They can learn to use tools to access hidden rewards, etc. And so what Garcia studied with rats was whether they can learn to avoid particular cues associated with foods. And so there were two cues and two reinforcers. The first cue was the size of the pellet, so the actual physical appearance of the food that the rat was being presented. The second cue was the flavor of the pellet, and so this is really how the pellet actually tasted. The first reinforcer was X-ray induced nausea. This is a delayed onset, so it would happen about 3 to 4 hours after the food was consumed, or after the exposure to the X-ray. Of course, the X-ray was given at the time that the food was consumed. The other reinforcer is an immediate electroshock. So, an immediate situation of pain. And so what rats were able to learn was to avoid the taste of a food that results in delayed onset nausea. And so they learned to pair the taste of the food with this X-ray induced illness. They also were able to pair the size of the food with this immediate electric shock. And so looking at actual physical characteristics of the food caused the rats to avoid those foods when they were paired with electric shocks. So the other two combinations, the flavor of the pellet with shock and the size of the pellet with X-ray induced nausea, the rats were not able to learn to avoid those pellets. So specific reinforcers match up with specific cues regarding that food. Same experiment was done looking at water instead of food, and here we have tasty water, which is water that has sweetener added to it, and we have bright noisy water, which involves kind of a lights and sound display that comes as the rat drinks the water. And again, paired with nausea-inducing X-rays and paired with electric shock. And again, rats learn to avoid tasty water when the reinforcer is X-rays that cause nausea. Rats learn to avoid bright noisy water when the reinforcer is immediate electric shock. In the other conditions, rats will not avoid those foods. So rats are able to learn some food avoidance. Rats are not able to learn other food avoidance based on this pairing of cues and reinforcers. The evolutionary interpretation of this is that learning, of course, depends upon the characteristic adaptive problems that the organism has regularly faced. So how do we explain this according to rats' evolutionary history? Well, rats are really everywhere on the globe. Rats are a species that, particularly because of high reproductive output and the fact that they're able to learn, they are able to exploit new habitats. And one way they do this is by experimenting with new foods, new resources. Some of these resources have toxins, and therefore they have learned to avoid the taste of the food that's paired with delayed onset nausea. Some of these foods are dangerous. They can bite, they can sting, etc. And so they've learned to pair the size, the noise, the flashy displays with foods that give kind of an immediate injury. So when the cue and the reinforcer mimic the kinds of situations that rats may have found throughout their evolutionary history, rats will learn to avoid those particular foods. Well, if rats can do it, can humans do it? We see certainly that learning biases have evolved in other species. We also have evolved central nervous systems, and it's not that far-fetched to then assume that we, in fact, have evolved learning biases. But many groups of people behave differently. We see a lot of variability in human behavior, or at least we think we see a lot of variability in human behavior. Actually, a lot of the variability that we see is tied to culture and tied specifically to the adaptive strategy or how resources are produced in that particular context. So we're not quite as different as we think we are. Behavioral variation among human populations is due to variation in the conditions that people experience. And so, as we're talking about different conditions, we have to recognize that this includes both strict ecological conditions as well as social and or cultural conditions. So when we find ourselves in different environments, when we find ourselves producing our resources in different ways, etc., we see variation in behavior. All right, so this first quote unquote learning bias is questionable at best. We have a long held assumption that we see sex differences in the kinds of problems that men and women can solve. And so the typical assumption is that men are better at spatial rotation and kind of awareness in space. Women are better at object memory. Women are better at language. And so this has led to, of course, hypotheses that women talk more. It's actually not true. Men actually say more words, though the ways in which we talk are very different. However, that's also due to our gender socialization from really an early age. So, but all of this is behind like the assumption that women can't parallel park, for example, which is actually not true. If women are told that they can parallel park and are taught how to parallel park, guess what? They can parallel park just as well as men can. Do we see some differences that are based on sex and thusly the hormonal profiles that each sex experiences? Probably. However, these don't seem to be innate sexual differences, and it's really hard for us with humans to have this perfectly controlled environment where we can separate out nature from nurture. Most of our behavior is not hardwired, but we're socialized to engage in particular behaviors over the course of our entire infancy and childhood. So, kind of trying to remove gender and raise genderless kids doesn't really work in our kind of context. What we do know is that humans are, and this is true, that humans are exceptionally good at learning faces. We even see faces in things that aren't living, like this tendency, I forget what the term is, but to see like the upper windows and the porch of a house looking like a face, or screws that are holding a hook on the bathroom stall door looking like a face. So we see faces even where faces are not present. We also are incredibly good at learning new vocabulary words when we are exposed to those words in our primary language. So we're not always good at learning two languages unless we are exposed to both of those languages when we are young. Language acquisition, most of it happens before about age 7. And so if we've heard multiple languages before age 7, our brain is kind of primed to pick up the languages that we've heard. So in our primary language, we are very adept at learning new vocabulary words. We're also good at understanding spatial relationships that are hard to learn in another mathematical form. So we can look at a graph and understand what, or intuit what that graph means, even if we don't know the mathematical formula that was used to generate that particular relationship in the graph. So math is actually hard for us somewhat when we're talking about just abstract numbers, but or when we're talking about some of these relationships and actually writing an equation for them. However, we are really good at guessing more and less, so relative amounts, and we are good at intuiting relationships between variables. And so we'll come back to this when we talk about a diminishing returns curve, but we're going to use a diminishing returns curve a lot in this class. We'll start talking about it next week. And I never ever at any point in the class ask you what the formula is for a diminishing returns curve, because honestly, we don't really care. We don't care what the formula is. Well, if we were mathematicians, we would care. But what's less important is the actual formula. What's more important is intuiting what that relationship means. And so this is something you're going to be exposed to starting next week, and it'll really continue through the rest of the semester. And then Cosmides and Tooby in the 1980s, they're two evolutionary psychologists, social psychologists that have been at a number of California schools, UCLA and UC Santa Barbara and such. They have demonstrated that we are able to detect cheaters in social contracts, even when we cannot solve that same problem in a non-social way. And so they put two hypothetical scenarios before people, and both of those scenarios, one involved you were working in a school office and you had to categorize students, the other involved being a bouncer at a bar. In these two contexts, the solution was that you have to turn over the cards that are P and not Q. But people did very, very well at solving those problems when it was a social contract, when you were the bouncer in a bar. They had an incredibly hard time solving those problems, even though the rule for the solution was exactly the same when it was this arbitrary, you work in an office and you're categorizing student files. So we are able to recognize when people are cheating in this social context that we may not recognize other problems that have those same particular characteristics. So this may be refuted, this gender difference. There was some recent research, 2008 and beyond, that looked at the role of gender priming in people's behavior. And so it worked with this typical stereotype that men are better at math and spatial reasoning, women are better at object memory and language. And so we had these spatial tasks that were investigated among a mixed adult sample. So this was predominantly undergraduate students, though there were some other adults included in the population. It was 161 men and women, and they were asked to complete these spatial rotational tasks. After a male or female gender stereotype activating task, participants then worked on this mental rotation task. So what this basically said was that you would be exposed to images that either reinforced your gender priming, your gender stereotype, or were opposite. So women were asked to be nurturing to crying fake infants, and that would be a reinforcing behavior or activation for gender stereotypes versus being asked to, I don't know, fix a car or something along those lines. Basically, there were times where women were primed or told to do this task like a man would do the task. And interestingly enough, when women were told to do the task like a man, they did. They were able to perform as well as men did on those spatial rotational tasks. When women were primed with very stereotypical female gender roles, they were not able to perform as well in the task. Men's performance did not vary. So if men were told, do this like a woman, think like a woman, etc., it didn't change their performance. They still performed that task like a man. So what does this say? Well, it implies that we've got a lot of socialization that we have to get over if we want to accept women doing tasks like men, if we want to accept women working in occupational fields that have very stereotypically been filled by men, etc., that we, as women, have to overcome a lot of biases in how we've been socialized according to our gender, in order to not handicap ourselves. So, it's very telling. So there's a growing mountain of evidence that natural ability differences are confounded by identity and our own subconscious self-stereotyping. These demographic expectations may be subtle, they may be overt, but they're always present and much more powerful than we've ever considered. So, we don't necessarily ever have the ability to disentangle nature from nurture, because the way that our nature develops is impacted by how we're nurtured. So, these early messages that we get as infants and young children impact our performance as adults. I mean, this should really kind of rock your world and make you question why we still find women in subordinate positions in the United States, why we are underrepresented in Congress, why we have yet to have a female president. All of these things. I mean, we tell our girls you can do anything boys can do, but yet we also tell our girls you throw like a girl. We tell our girls that what they do naturally as girls isn't good enough. So just something to be conscious of when you go on and reproduce and are perhaps parenting girls. All right, so we do engage in social learning. We are capable of imitation. Other non-human primate species are not necessarily capable of imitation. We will imitate solely for the purpose of imitating because someone's basically telling us, do this just like I do. Other primates will solve social learning tasks, but if they see a shortcut, they will cut out any kind of unnecessary steps. So I'm trying to remember. Yes, there are some videos on the next slide, and one of those is going to show an experiment that was done with young children and with chimpanzees. And so at first, both children and chimpanzees are presented with an opaque box. The researcher does a certain number of movements, like they poke a stick in the top of the apparatus, they move a rod, they tap it in a certain way, and then they lift a door at the bottom, and there's a gummy bear or whatever. I can't remember what particular treat was used, but there's a reward. And so when the box is opaque, and chimpanzees and young human children have watched all of these steps that the researcher does, they will perform each step in turn, and then they will lift the door and get the reward. And so the interesting thing becomes evident when the box is changed to basically see-through. And so when it's a clear box, a transparent box, what you're able to see as an adult is that none of the steps are necessary except for simply lifting the door and getting out the reward. That all of the tapping and moving of rods and shaking and such is irrelevant. Those are not necessary to be able to get the reward. Well, right away, what chimpanzees do is simply lift the door and get the reward. They cut out all of those unnecessary steps. What young human children do is every step that the researcher did. So this demonstrates to us that we as humans are primed to imitate, whereas non-human species may not be. This is really, really, really important with respect to our ability to transmit information culturally. One of our big advantages evolutionarily is the fact that we can consolidate cultural information. That means that we can amass large quantities of cultural information and pass it on through oral traditions, or once we innovated writing, through texts. And we can learn from the experiences of people who are quite disparate from us in time and space, from people who lived hundreds, if not thousands of years ago. We can, read Greek tragedies. We can learn from Socrates and Aristotle and Copernicus and Galileo, that we can amass large, vast quantities of information that give us a leg up, that allow us then to have kind of an expectation of how we might solve something when we are faced with a new and novel situation. So, we are faced with a new threat, a new kind of ecological context. We can first research and see when the last time in human history, whether it's oral history or written history, that context was experienced, and we can see how they solved it. So this is really a huge, huge, huge cultural adaptation for us, that really goes hand in hand with us becoming really the dominant anthropoid on the planet, was our ability to consolidate cultural information. So here are the web addresses for the videos. They're both fascinating, both dealing with some of these differences between chimpanzees and human children. So how then do we account for culture? Well, an interesting way to think about it is that culture is learned behavior, right? That culture is information that we've acquired through social learning. And so we can learn ecological skills through social learning. We can also learn social skills through social learning. So it consists of a set of rules or norms about what behaviors are allowed or preferred that are enforced. So we learn to pair cues or indicators with reinforcers or outcomes. Culture is thusly an environment that people create and rules that people create, rather than being composed of physical and non-human biological elements. So when we are trying to get at answers as to how certain behaviors evolved, or what our evolutionary ancestors would have behaved like, etc., we aren't really able to separate out ecological environment from cultural environment. So culture is as important a factor in behavioral differences as ecological environments are at predicting these behavioral differences. And so it is enough to, to attribute some particular behaviors specifically to cultural differences. Cultural rules can also produce high levels of conformity to arbitrary patterns. Think about, I don't know, I'm really just trying to pull something off the top of my head here, but think about standards of dress, right? We freak out if we see exposed nipple on a female. We don't freak out if we see exposed nipple on a male. Hunter-gatherers, unless they live in very cold environments, are readily going to be exposed to both male and female nipples, and there's not some kind of inherent shock or taboo surrounding the exposure of the female nipple versus the exposure of the male nipple. So, we can create arbitrary rules of dress. It used to be that men wore tights and dresses and wigs, and, relatively recently, it's more that women wear tights and dresses and wigs. Baby boys used to be dressed in pink. It was a sign of status. Now, if we see a baby dressed in pink, we assume it's a girl. So, many of these cultural rules are really essentially arbitrary and reinforced through both like conscious and subconscious social reinforcement. Think about middle school, right? How did you learn how to dress in middle school? It wasn't direct instruction. It was the looks that you got when you wore something that violated whatever arbitrary social norm was present at your middle school. It's easy to show that socially learned information about the world affects how we interpret aspects of the world. And so, for example, this picture has been presented to American school children and Chinese school children, and they have a different interpretation. If I ask you how would you describe that fish at the front, what is your answer? Most of you probably think, oh, he's a leader. He's leading the other fish where they're going. And that is a very typical American response, individualistic kind of response. What Chinese school children see in that particular picture is a social outcast, a fish that's been ostracized by the others. And that's because their society and their socialization from very young ages is more about collectivism rather than individualism. And then when we look at Chinese American students, we can find that the priming condition affects how that they interpret that particular image. And so on the left, we have American primers, the flag, big band music, Marilyn Monroe, Superman. On the right, we have Chinese primers. I can't remember what the top one is, but we've got scholars, we've got monks, we've got samurai warriors, we've got images of kanji, which is their script. In the middle, we have neutral primers. These are just three-dimensional shapes. And so if Chinese American students are primed with Chinese primers, they respond more like Chinese students that fish is an outcast. If they are primed with American primers, they respond more like American students that fish is a leader. And if they're primed with neutral primers, it's about 50-50. So the both our experience during socialization, during our upbringing, and our immediate social cues both matter and both influence how we interpret situations. I'm sure you guys can recognize that the people who change culture old are not the older people who are in a dominant position. So in America, it's not going to be old white men who change culture, right? It's going to be women, it's going to be minorities, it's going to be youth. And we are much more amenable to cultural differences, to learning them and even practicing them if we are exposed to them when we are younger, when our brain is more plastic. And so here's the data that talks about this priming condition and how Chinese American students interpret it. So, social learning can be favored by natural selection when conditions make it difficult or costly to assess the best course of action. You don't have time for trial and error, for example. It's a life or death situation. You're starving. You've got to figure out whether you can safely eat this food or not. What are you going to do? You're going to look to people who are there eating and see what they eat, what they avoid, and then consume the foods that they consume. So, we take a lot of shortcuts through social learning to learn about appropriate behaviors that are going to make a difference in our survival and reproduction. If such copying doesn't rely on verification of the individual costs and benefits, then behavior patterns that are non-adaptive can become common. Think about obesity in a modern context, right? We don't have a lifestyle that favors physical activity and favors healthy eating. Plus, we have a biological tendency to favor foods that are calorically dense because of our evolutionary history. You'll learn about that preference for fatty, sweet, and salty foods in the film next week. And so when we have ready abundance of or easy access to foods that are calorically dense, we end up suffering from obesity that's not adaptive in the long term, that's not adaptive at like the societal or population level. The above situation is usually not met, so we tend to not copy maladaptive behaviors, but we just gave an example of a context where we could. All right. So in summary, remember the types of selection, that is stabilizing, directional, and disruptive. Know the difference between genotype and phenotype and what we mean by heritability, and recognize these situations of can behavior evolve? What do we mean by reaction norms and phenotypic plasticity? Recognize that we are predominantly concerned with the ultimate level of causation, and then tie all of this together in this addressing of learning biases of cultures, learned behaviors, and the benefit that we get as a species of being able to socially learn.